So here's a breakdown of some common types of data visualization. So we'll do a quick overview of dot plots, stem and leaf plots, box plots, pie charts, bar graphs, histograms, and scatter plots. Now this is a dot plot, which we've talked about before, and as you saw in the numeric variables video. So with this plot, we just have the x-axis along the bottom, the horizontal axis, and that, in this case, we're displaying a range of temperatures, daily high temperatures in Katz, Colorado in April. And each dot on this plot represents the high temperature for one day in April in Katz, Colorado. So if we look at the very lowest point, that means that one day in April, the daily high was 6 degrees Celsius. If we look up here, we can see that for one day, the high was 19 degrees Celsius. There were 5 days with a daily high of 10 degrees, 3 with 11, 4 with 12, and so on. So we can see the ones that are stacked up higher just means that there's more data for that particular value in our set. Okay, so we can see how many days had a temperature of at least 16 degrees Celsius. So at least means including, so we'll count these two, plus everything at least implies greater, so we'll count 1, 2, 3, 4, 5, 6, 7. So pretty straightforward. Now this one, you are unlikely to see all that often. And really, I'm just showing it to you so that you can say you've seen it once, because textbooks tend to mention stem and leaf plots for some reason. So if you ever have another statistics textbook and it says stem and leaf plots, at least you've sort of heard about it. So here, this thing on the right is the stem and leaf plot. This is the data visualization. So we have organizing and presenting the data visually. It is presenting this set of data that we have on the left. So we have what is called the stem, which in this case is the first digit. It depends on, if we had triple digit numbers, then it might be 2 digits, for example. But in this case, it's the first digit, or the tens column of the number. And to the right is the leaves. Or are the leaves. So here we have the stem of 0 and the leaf of 4. That's this number 4. Then we have 10, 17, and 18. So it's almost like a shorthand where we're putting the tens on the left so we don't have to include that 1 each time. Then we can see we have 23, 23, 24, 27, 28, 32, 32, 32, 33, 35, 37, 37, and so on. So it is a little easier to look at, and we can see, there are very few data points in the low end, very few in the high end. They're mostly clustered in the middle, which we can't really see by just looking at this set of numbers, right? It's harder to see visually just by looking at the numbers. So this does help to organize it a bit, although, like I said, these are not super common. I think these are a bit outdated. Now this is called a box plot, hopefully for obvious reasons, because it has a box in the plot. I'm not going to go into a lot of detail on this here, because there's going to be a whole guided notes video that talks about box plots coming up very soon. So this is just so you can see it. This is called a box plot. You'll learn more about it coming up soon. It's also called a box and whisker plot sometimes. So the box is in the middle and the whiskers are the things that stick out on the sides. Now this is a chart or a visualization that most people are very familiar with, a pie chart. It's good for displaying nominal or categorical data. So if you are just describing like what proportions of different categories you have, then sure, a pie chart will work well for that. However, statisticians and researchers, we really don't use pie charts very often. They're not the most helpful for a lot of reasons. I mean, it lets you see relative proportions, which is nice, but it doesn't really show us, like, how can we tell if these are, significantly different from each other? It doesn't give us a whole bunch of information. We don't even know how many people are in this, right? We don't have a count. These are just the percentages. Okay? So pie charts, while they look great and they're easy to read most of the time, we don't actually use them very commonly in statistics. Bar graphs we use quite often. So as described in the video that you've watched, bar graphs look very similar to histograms, but they have a few key differences. So bar graphs, you'll notice we have gaps in between the bars. The bars are not pushed right up against each other. Excuse me. The x-axis, what we have down here at the bottom, are categories. So in this case, the nicest fruit versus the meanest fruit, we have apple, orange, banana, kiwi fruit, blueberry, and grapes. So they asked people, which fruit do you think is the nicest? And then this bar graph is showing us that 35 people felt apples were the nicest. Looks like about 30 thought oranges were nicest, and so on. So again, a key thing that tells us this is a bar graph is down here on the x-axis, we have words. We have categories. It's not a range of numbers. We use bar graphs to show categories, something related to categories. Now, bar graphs may have count or frequency on the y-axis, similarly to histograms, which is what we see here with nicest fruit. So this is the same as just count or frequency, the number of people who chose this, the number of people who chose that. So sometimes we use bar graphs in this way, but often we use bar graphs to sort of summarize data in terms of, often what we do is in terms of averages, or to compare different groups, averages from different groups. So we see this on the right-hand side. This bar graph is showing us the length of male versus female fish. So we see that the male fish, right, it's split by males and females. The male fish, it looks like the males are quite a bit smaller in length. I guess they wouldn't be shorter if they're fish. Are shorter in length than the females. The females, it looks like, are about twice as long as the male fish, which is interesting, right? So here, these numbers on the left-hand side, these are not how many male fish and how many female fish there were. This is the actual length. It's the average length for all of the male fish and for all of the female fish, right? So we can see the average for the males was about 10, and the average for the females was about 20. This is not just counting, right? So bar graphs we can have something different on our y-axis other than frequency. Histograms on the other side, or on the other hand, there we go, are always displaying frequency along that y-axis. It's always count or frequency. So another thing that we notice about our histogram is along the x-axis, you'll notice it's a range of numbers, right? It's not categories of something, it's actual numerical values, and we're plotting along a range of values along the x-axis. So if you see something that looks like a bar graph, but it's got a bunch of numbers at the bottom and the bars are all pushed up against each other, not actually a bar graph. It's a histogram. Histograms we use to display frequencies when we just want to see how many of each score or how many of each measurement we have for a sample. For example, here we can see how many people fall along these age ranges. So in their 20s, in their 30s, in their 40s, in their 50s, and so on. Notice that there is a gap right here between 80 and 90. So this means that in this sample, there was nobody in their 80s. right? So if you see a gap in a histogram, that just means there's nothing in the in-between space. And the reason why we like histograms so much, that we often start by looking at histograms, is because they're really good for seeing the shape of distributions. And hopefully this classwork is going to show us or kind of illustrate a little bit of why do we care about the shape of distributions? Why is that more helpful for us in some ways than simply looking at a bar graph like this? And we will also be talking in the future about scatter plots, called scatter plots because it looks like a scattering of dots on the graph. Scatter plots, again, I'm not going to go into much detail now because we're going to get into a lot more detail with scatter plots in a few more weeks. All right, so once we get closer to talking about something called correlation and regression, then we'll start talking about scatter plots and how you read them and how you make them and why we choose to do a scatter plot versus something else. Now, just another quick note to practice on reading histograms. So again, you want to look at the numbers along the x-axis. These are the measurements. In this example, we're looking at the size of different houses on Prince Street in terms of square meters. So we see number of houses, that's the same as frequency or count. We're just counting how many houses. We can see, for example, that 1, 2, 3, 4 houses on Prince Street were smaller than 100 square meters. We could see that only one house on Prince Street was larger than 250 square meters. 5, right? 1, 2, 3, 4, and 5, since it's scaled by ones. 5 of them were over 200 square meters. So this is going to, I just want to illustrate a little bit of how we read this histogram. So again, the numbers along the x-axis represent the measurements in our data set. And then we look how tall the bar is, tells us how many measurements were in that kind of range of numbers, right? Between 50 and 100, between 100 and 150. So with histograms, just keep in mind, the taller the bar is, the more data is clustered in that set of numbers. So hopefully that helps you, helps prepare you to keep going with this classwork and get some practice reading histograms.